Hello, everyone. This will be our recorded discussion for measures of possession. Um, these are our learning outcomes for this topic. So at the end of this, you will be able to define what is a quartile, a decile, and a percentile as a measures of possession, and also be able to use this or to use them to analyze assessment scores. Also, locate its measures of position for a given n group and group data. So, for definition of terms, measures of position helps us to understand more where a specific value falls within a data set, unlike with measures of central tendency, in which we get the most scores. Here, we refer or we focus on a specific value. So note that a data is divided into equal parts, and it can measures of position can provide insights as to where this specific value is located when we divide the distribution into equal parts. Well, again, as our learning outcome earlier, we will cover a group and group data. So these are our measures of position. So there is what we called quartile, which we have the first decile, the second, no, sorry, first quartile is equivalent to our 25th percentile. Second quartile is equivalent to our 50th percentile or our median if we're talking about central tendency, and our third quartile is the 75th percentile. There is also decile, in which the data is divided into 10 equal parts. So definitely we have first decile to the ninth decile. And of course we have percentiles, which we divide the score into 100 equal parts. So just to give you a clear what we call this illustration, for example, let this number line be your entire data set. If we are concerned with the quartile, then that means to say we just need to divide this entire distribution into four, and that we need to cut it by three. So that means one, two, and three. So now we now have the first quartile, the second quartile, and we have the third quartile. However, also, if we're talking about decile, which we divide the entire distribution into 10 equal parts, making having as a 9 positions. So that gives us the first, second, third, fourth, fifth, sixth, seventh, eighth, and the ninth one. So that means to say our first decile will start here, second, third, fourth, fifth, and so on. Now, we don't have 10th decile and we don't have fourth quartile because that is already the top score. I mean, there is no, when we talk about location, we are not going to discuss, or we will not be talking about the last number. We will be talking about the location of that last number. So similar also with percentile, we divide it by 100. So we will have the first and the 99th percentile. So what does it mean? If a score is located on the first quartile, for example, then that means to say that learner is performing lesser than the 25% of the class. Okay? Similar with if the score is located around the second quartile, that means to say that learner is performing 50% lesser than the performance of the class, right? So let's have the practice exercise. So for ungrouped data, let's have this um, provided example. So we have 3, 4, 6, 7, 9, 5, 8, and 10. Now, the rule is, since we're talking about position, we have to arrange this. And that will give us, if we're going to arrange the data set, that will give us 3, 4, we have 5, 6, we have 7, we have 2 students who scored 8, we have 9, and we have 10. Now again, what we're going to solve is the first quartile, the 30th percentile, and the 5th decile. Now, the first is, no, after arranging, next step that we need to do is to solve for the location of the quartile, percentile, and decile. So the location will be dependent on what is the given or what is being asked in this dataset. For example, for first quartile, that means to say we have to look for the location of the first quartile. So mean to say we have to say k times n plus 1 divided by 4. So if we're going to have a similar formula with the percentile and the decile, so for quartile we have k times n plus 1 divided by 4. For percentile we have k times n plus 1 divided by 100, because we're talking about percentile. And decile we have k times n plus 1 divided by 10. Okay, so now let's go back to the given problem. So let's look for the location of the first quartile in this data set. So take note that our n is 9, and we're looking for the first. So that's 1 times 9 plus 1. That gives us 4. Hence, we'll have 10 divided by 4. So you'll have 2.5. So if you are just asked to estimate, you can just round up this number. So when you say round up, that means to say we're referring to the third location. So hence, in the arranged number or the arranged data we have, we will be considering 5 as our first quartile. So that means any student who score 5, 4, and 3 is already on the 25th or on the 25% below bottom 25% of the class. Okay, now how about for the 30th percentile? So for the 30th percentile, again, locate for the location first of the 30th percentile. So that gives us 30 times, this would be 9 plus 1 divided by 100. So this is 300, given that 9 plus 1 is 10 times 30 divided by 100. So we are looking again for the third location. So still, by estimation, our P30 will be 5. So do not forget always to present your score like this. Put it in the box or encircle it to highlight that that score is the located position in the given distribution. Now last we have the fifth decile. So the fifth decile is equivalent to 5 times 9 plus 1 divided by 10. That gives us 50 divided by 10. So we're looking for the fifth location. So we have 1, 2, 3, 4, 5. That gives us, sorry, that gives us 7. So the fifth decile is the score of 7. Okay? So now, these solutions are actually just for estimation. How about we're referring to the exact answer? So there's what we call estimation versus interpolation. The first one that we did is estimation. However, there are cases that you will be asked for the exact answers, and that's the time when we need to interpolate. Okay, so let's have the same example earlier. Let's just arrange it again. 3, 4, sorry, that should be 5, 6, 7, 8, 8, 9, and 10. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So now we're solving for the 75th percentile. So again, we're gonna look for our location of the 75th percentile. If this is the distribution, our n is still 9. So that gives us 9 plus 1 divided by 100. This is 750 divided by 100, and that gives us a 7.5. Now, if we're going to estimate, we'll just get the 8 square. We're just gonna round up. However, we are asked to interpolate. So that means to say we will be focusing on the 7th and 8th score. The 7th score in the distribution will be 1, 2, 3, 4, 5, 6, 7. And this one will be our 8. So that means to say that we're dealing with 8 and 9 score. So in between these scores, from 8 to 9 lies our P75. But again, we will be looking for the exact value. So the best way to do it is to state your unknown and look for the difference of those two scores. So that would be 8 minus the 7 score, or 9 here in the distribution, 9 minus 8. So you have 8 score minus the 7 score. That gives us 9 minus 8. Then that's 1, right? So the 7 score is already 8. So you will put that here as our 8 according to our distribution, plus the decimal that is left, which is 0.5, times the difference that we have solved earlier. And that gives us 8.5. So hence, the exact score when interpolated is 8.5. However, if we're going to estimate, will be 9. So I hope that there's a difference between estimation, looking for the measures of position, and interpolation in your end. All right, now let's proceed to group data. When we say group data, of course, there is a frequency, and this will be our formulas, working formulas. So actually, if you will just observe, it's just the same. What's just different from each other is that, of course, here we're referring for the quartile. This one, we're referring for the percentile. And this one, sorry, it should be just 10. We're referring for the decile. All right, so let's solve for third quartile and the 50th percentile. So let's say we have this, our class interval, and we will be looking for quartile, the third quartile, and the 50th percentile. So first, let's have the, going back to this formula, we need to have the lower class boundary and the lesser cumulative frequency. So you know that when we talk about the lower class boundary, that will be the lowest number in the class interval minus zero point 0.5. So here this will be 0.5, 45.5. This is 40.5. This is 30.5. This is 30.5. This is 25.5 and 20.5. For the lesser cumulative frequency, we always start with the lowest class interval, so it should be from going up. So that gives us 6, 18, this is 27, this is 38, this is 46, and this is 4. Now we're complete with the table. We proceed to, first let's solve first for the third quartile. Let's proceed to where is the third quartile class located. So how do you solve that? We use the formula k times n divided by 4. So whatever is the result of this, and we locate that to our lesser cumulative frequency, will be our third quartile class. So we'll have this one as 3 times 50 divided by 4. So that gives us 150 divided by 4, and that would be 37.5. So with that, we have already our, if we're going to locate this 37.5 in the lesser cumulative frequency, this will be our quartile 3 class. So from there, we can now solve for the exact value of our quartile 3. So it will be obvious that our score will just be around this. Our third quartile will just be around this 36 to 40. So we'll have that is 35.5 plus 37.5 minus the lesser cumulative frequency below, which is 27, divided by the frequency of that class times the class interval, which is 5. Remember that our formula for quartile when we're talking about group, is the lower class boundary plus kn divided by 4 minus the lesser cumulative frequency below divided by the frequency of that class times the class interval. So that is just pattern to this here. And when we solve this, you can check it in your calculator. So we'll have 35.5 plus 37.5. 37.5 minus the 27 divided by 11 times 5. So that would be around 40.27. So notice that it did not actually reach the next class interval. So it's still between the boundary. And this will be our third quartile. Now, we move to the next missing or the next unknown position in this problem. So in the next slide, I will just be writing the lower class boundary and the lesser cumulative frequency. So this is 45.5, 40.5, 35.5, 30.5, 25.5, and 20.5. So for the lesser cumulative frequency, we have 6, 18 rather, this is 27, this is 38, this is 46, and 4. Now, the next to solve is again so we're going to use this formula plus kn divided by 100 minus the lesser cumulative frequency below divided by the frequency of that where P50 is located times the class interval. So remember that we have to look for the 50th class. So you say 50 times our n, which is already also 50. Sorry, this should be 50, by the way. 46 plus 4 is 50, divided by 100. So that gives us the 25. Where is this 25th score located? So obviously, that will be in this area. So this is where the 50th class is located. Now, it's just easier to find our lower class boundary, which is 30.5, plus our 25 earlier, minus the cumulative frequency below, divided by 9 times 5. So if we're going to put that in a calculator, that will be 30.5 plus 25 minus 18 plus 25 minus 18 divided by 9 times 5, which is our class interval. So basically, our 50th percentile is 34.39. So notice that still in the class interval we have here. And also, this will now be our median, our second quartile, and our fifth decile as well. So these are just the same, right? So additional also information, when we talk about measures of position, there is what we called interquartile range. So when we say interquartile range, it is just actually the difference between IQR or interquartile range. That is just the difference of Q3 minus Q1. So for example, we're going to look for, because P75 is also our third quartile. So if we're talking about, and let's say we'll have the quartile 1 going back here, note that we round this up, but if we're going to have the exact value, that would be, this is second and this is third. So therefore, we'll have our P25 or quartile 1 will be 4 plus the difference of this. So that would be 0.5 times 1. That gives us 4.5. So if we talk about quartile range, this is the exact. This is the interpolated, and this is the estimated. So if we're talking about interquartile range, that would be 8.5 minus the 4.5 we have in the previous slide. So that gives us 4 in this given data, right? So I guess that would be it for measures of possession. Thank you so much.